Hello, science students. Today we're going to talk about what is a chemical reaction. So this is kind of what, in a way, the whole school year has been building to. We learned about energy in physics. We learned about different elements. We've learned about ionic and covalent compounds. Now we finally get to talk about what is happening when a reaction occurs. So our goal is to be able to describe a chemical reaction. So before we get too far into it, let's look at a couple definitions. So the first one's probably the more traditional one. So a chemical reaction is a process in which the atoms in one or more molecules are rearranged. It could also be compounds, but basically the idea is they're going to get rearranged so they're now in different positions, or they're interacting differently, or those bonds we've been talking about have changed. The definition I kind of like for you guys that I think makes more sense, maybe it's easier to remember, is a process in which chemical bonds are broken and remade differently. So if I have a compound and I break it down and put it back together, has a chemical reaction occurred? Not really, because I still have the same thing. Something has to be rearranged. Let's talk about, in a minute, we'll kind of see how that works. Let's talk about what we would have to see in order to be convinced that a chemical reaction has actually taken place. So evidence that a chemical reaction has occurred. Now, again, important to keep in mind, there are exceptions to these. Just because this has happened doesn't necessarily mean a chemical reaction has occurred. And just because you don't see one of these, it doesn't necessarily mean a chemical reaction hasn't occurred. These are just things that we use as evidence that are relatively convincing. Usually a reaction will have one or more of these, but not always. So the first one's the odor changes. Okay, it smells differently. So if you've ever baked, you're kind of smelling the result of a little bit of a chemical reaction. The color changes. There's a lot of chemical reactions in which the color changes. And color indicates that we now have a new substance, because different substances will often have different colors. Another one is there's an energy transformation. This is really evident in the reactions that you guys have done already. So we did the yeast and hydrogen peroxide reaction. When we did that, it was exothermic. It released heat. When you put the vinegar and the baking soda together, it gets pretty cold. It's endothermic. It's absorbing heat, so endothermic. And energy transformation has occurred. Another one, light is emitted. So sometimes it releases energy as light. So you've heard of phosphorescence or bioluminescence. That's the kind of thing you're seeing there. Light is being emitted as a result of a chemical reaction. Sometimes you'll see gas or bubbles. Both of those reactions, the hydrogen peroxide and the yeast, and the vinegar and the baking soda, both of those released a gas and they bubbled. So a phase change occurred even though we didn't heat or cool the substances. A precipitate forms. This one's something we haven't necessarily seen yet, but if I take two liquids and I mix them together and a solid forms at the bottom, possible that a reaction has occurred because something in those two chemicals is no longer soluble. It can no longer dissolve, and therefore it becomes a solid, and you'll see that as a result of the reaction. Good. So those are a few different things that you might see if a chemical reaction has taken place. Now, this is where the chemistry action really takes place, is we need to be able to describe these chemical reactions. And the way we do that is with a chemical reaction equation. So this is a lot like any equation in math. Whatever goes out or whatever goes in must also come out. Okay, so the two sides kind of have to be equal in that way. So a chemical reaction equation shows the reactants, products, and direction of a chemical reaction. Let's take a look at what that looks like. So first example for us, here's that hydrogen peroxide reaction. There was a catalyst in the yeast that makes the hydrogen peroxide break down, and it breaks down into water and oxygen gas. But we started with hydrogen peroxide. So this is what we call a reactant. It comes at the start of the reaction. A reactant is a starting chemical. And then we ended up with some products. So products are at the end of the chemical reaction. And our products for this one were some liquid water and some oxygen gas. The arrow indicates the direction. The hydrogen peroxide became the water and the oxygen. Second example, a little bit more complicated. So this time we have sodium hydroxide and some hydrochloric acid. We'll learn how you guys can read those later, but for now, this will work for us. they're before the arrow, and the arrow is going to the right. Therefore, these are also the reactants. In this class, I will never put the reactants on the right and go in the opposite direction. That's sort of bad chemistry notation, so we won't ever do that. That means the molecules or compounds after the arrow, these must be our products, which in this case is NaCl, sodium chloride or salt, and water. So there are a few things you should get out of this. What's a chemical reaction? So in this, you can see that some bonds were broken. We formed new chemicals. In this one, some bonds were kind of swapped. The sodium's now with the chlorine, the hydrogen's now with the OH, and made water. So the bonds have been traded around. The atoms are now associated with different elements. So a chemical reaction has occurred. In this reaction, you guys know from experience now that when hydrogen peroxide breaks down, this is exothermic. So in this reaction, that's one way we would have known that a chemical change had occurred. And finally, we now can recognize in a chemical reaction equation where the reactants are before the arrow and where the products are. The things that we'll end up getting after the reaction come after that arrow. Thank you for watching, and have a fantastic rest of your week.